Hello, I'm Professor Dorn. I'm a physical geographer at Arizona State University, and I wanted to explain the essence of the Big Island of Hawaii video game-based lab. What it's all about before you charge in and go ahead and do the lab. The best way for me to explain this is for you to look at the game itself and also a graphic that I particularly like about that explains physical geography. This is the video game or the geovisualization, basically a GIS of the entire Big Island of Hawaii. You may hear your computer begin to heat up. That process will take about 7 minutes for the entire island of Hawaii at 30 meters resolution to slowly build. When your game starts up, so don't worry about it, the computer will heat up, but then after 7 minutes, the processing required will greatly decrease. Um, where the game starts is on the Kohala volcano. So I'm very slowly using the mouse to pull back and get an overview of Kohala volcano. The game is basically a GIS of a landsat layer, the dew point where red shows a high dew point and blue shows a low dew point. And dew point is an index or a measure of the amount of water vapor in the atmosphere. And then rainfall, where more aqua green blue is higher rainfall and darker brown is lower rainfall. Physical geography is a truly integrative environmental science that asks the question, why is a place unique? By investigating the processes that you see in this graphic of climate, hydrology, plants and animals or biogeography, landforms, geology, the underlying material, and soils. This game allows you to explore the physical geography of Hawaii, of how it all works. The only piece of the puzzle that you really can't dig into is soils. So let's start with the biogeography and the climate and the water aspect of the lab. Kohala is an amazing example of what's called a rainshadow effect. You're looking to the northwest from the top of Kohala, and on the northeast facing side of the island to your right, the trade winds are forced to rise up over Kohala, dump its rain with the rainfall maximum on the slopes of Kohala. And then when you get to near the top of Kohala, the amount of rainfall begins to decrease. And then when the air goes on the western side of the island, there's a very sharp rain shadow. So if you examine the Landsat image, you can see the rain producing rainforest on the trade wind facing side and the rain shadow. So part of the lab is for you to explore the processes of how rain shadows work. And then also displayed in Kohala is the power of water in cutting canyons. In the lab, you'll measure the depth of the canyons and the amount of erosion that's required, all produced by the abundant rainfall that causes landsliding and floods down these massive, beautiful canyons. The biogeography aspect that you'll look at is investigating something called plant succession. But I'll first delve into the volcano aspect in terms of the geology of physical geography, and then use that to get into the biogeography. There are 5 major volcanoes on the Big Island: the Kohala volcano. And now I'm going to use fast travel in the menu to jump to the top of Mauna Kea. Mauna Kea is a volcano that hasn't seen active lava flows in the last few thousand years. The Kohala volcano you see in the distance hasn't seen active lava flows in about 1 million years. This island has a volcano here called Hualalai that is somewhere between fairly inactive and massively active like Mauna Loa. It's called Hualalai. and you're jumping to the top of Haleakala Volcano where there are active vents. You can see the depression of places where the volcanoes collapsed and where eruptions have spewed out. And there are historic lava flows that have come from Hawaii. If you look down at the Kona coast, you'll see some historic lava flows as the dark black texture. But there's no question that if you go to the top of Mauna Loa, it's extremely active. There is a rift zone on the northeast side and a rift zone, let me spin it around, on the southwest side, a very active, very dark black lava flow. And of course, there's the Kilauea Volcano, with its active caldera where the Hawaii Volcano Observatory rests. So if you look at the slope of Mauna Loa in the distance, so let's take the bunny rabbit and hop over from Mauna Loa, from the Kilauea Volcano to go up the slopes of Mauna Loa, you can see that what I discussed, plant succession. I'm going to jump from very recent lava flows to rainforest. So the dark green is the rainforest color. The reason why you have steps in the game is that the digital elevation model has a spatial resolution of 30 meters. And every time that there's a break in topography, there's a jump in elevation. Do you see the different colors of the lava flows? The ones that are older than about 70 years have rainforest on them. The ones that are about 10 to 30 years old have this kind of brownish, grayish color, tannish color. It's because the forest is beginning to reestablish itself, and this is the way it looks in the Landsat image. So we jump back to a lava flow that's about 20 years old, about 100-year-old lava flow that has rainforest on it, the beginning of a forest after about 15 years, and then the very recent historic lava flows that are within maybe 5-10 years old have this dark black color. So what you're seeing visually is called plant succession. The idea is that a lava flow restarts the clock on how plants reach what's called a climax or a mature vegetation community. And what's stunning about the Big Island of Hawaii is that you can see in this laboratory, so I'm going to go to the Kona International Airport here for you to see it, the same concept of plant succession from the very black historic lava flows. But the time scale of succession on the rain shadow drier part of the island that you see here is much longer. For you to begin to see the light green coloration, hold on to your hat. This color here takes about 10,000 years because it's a desert scrub vegetation with so little rainfall. You just get 600 millimeters of precipitation, or even less compared to over 2,000 on the rainy side. And the landforms of the Big Island of Hawaii include glacial deposits. So I'm going to jump to the top of Mauna Kea volcano and ask you to look at this color of this kind of whitish material. These are glacial deposits. There used to be an ice cap on top of Mauna Kea, and you get to measure the thickness of the ice cap and what the volume of the ice cap used to be. In summary, this lab asks you to analyze the entirety of physical geography by exploring the Big Island of Hawaii. I hope you have fun and earn lots of points. Thank you.